Hi there, this is Penelope. This is a video on some extra questions that you really need to do before attempting trig 3 on MyMathLab. And these problems involve adding and subtracting waves, as in trigonometrical waves, of the same frequency and rewriting them as a single function. Now, there are four types that you might come across. You would need to write it, and this is the one that you'll have in the exam. You'll have something like this. You'll be asked to rewrite it like that, in that format. And in this case, this is just a summary of what's in the textbook, that alpha, that one, is the inverse tan of b over a. Now, if you're asked to write it in this format, which the textbook does have problems on this, and it also has problems like this in MyMathLab, then you need to use this rule. And this time the inverse tan of, or alpha is the inverse tan of negative a over b. If you're asked to write it in the format r sine omega t minus alpha, alpha is equal to the inverse tan of b over a, and if it's in the format of r cos omega t minus alpha, alpha is in the format or found by that. Now you still have to be a little bit careful. You'll be told where alpha has to be between 0 and whatever. You need to also note whether it's in radians or degrees. But these four are the only possible possibilities. But the first one, as I said, this first one is the one that you'll have in the exam, and you'll be given the formula for finding that and for finding r. And r is the same in all of them. It's the square root of a squared plus b squared. What I'm going to do here is I'm going to do it the long way, but after this you just need to use the rules, but you probably need to see the background so you can see where the rules come from. Now for this particular one, the angular frequency is 2, so omega is 2. From our list of trig identities, we've got one that says that a sine omega t plus alpha is equal to a times sine omega t cos alpha plus sine alpha cos omega t. So what we've got here is we need to look at what we've got. We've got a sine 2t plus alpha, so we know that much, and that's going to be equal to a big brackets sine 2t. Remember, we don't know what alpha is at the moment. That's what we need to find. Cos alpha plus sine alpha cos 2t. And let's compare that with what we actually have. What we have, according to the question, is a sine 2t. What I'm doing is I'm multiplying out the brackets first. 2t cos alpha plus a sine alpha cos 2t. Now I'm going to compare that with what we have, which is 5 sine 2t plus 7 cos 2t. Now let's just change colour here. You can see the sine 2t, that's easy, so I'm not going to cross it out, but it's just dotted out. What we've got left is a cos alpha. So a cos alpha must be what's equal to 5. And if we look on the other side, you can kind of see the cos 2t bit. And what we've got left is a sine alpha, and that must be equal to 7. So what we've got is we've got that a cos alpha is equal to 5 and a sine alpha is equal to 7. Now let's just put that in a little diagram. The hypotenuse is going to be a, and from our basic trig knowledge we know that the horizontal is going to be 5 and the vertical is going to be 7. That allows us straight away to work out what a is. A must be the square root of 5 squared plus 7 squared, which is the square root of 74. And if it's not a nice number, just leave it as the square root of 74. But we can also take what we've got and say that sine alpha is 7 over a, which we now know to be 7 over root 74. And we know that cos alpha is equal to 5 over a, which is 5 over root 74. And then using both of those together, we could say that tan alpha was equal to 7 over a over 5 over a, because you remember that tan is equal to sine over cos, and that gives us then that tan is equal to 7 over 5, which allows us to find alpha. Alpha then is equal to the inverse tan of 7 over 5, and in radians, because we're in terms of t, so alpha is then in radians equal to 0.9505 if we've gone to 4 dp. That means we can now say that 5 sine 2t plus 7 cos 2t is equal to root 74 sine 2t plus 0.9505. Now, if we'd been asked for it in degrees, we could have changed it. If we were using the formula, we would have gone straight to the fact that a was equal to the square root of a squared plus b squared, which is the root 74, and that alpha is the inverse tan of b over a, which gives us the result as we had before. Now, we could do this by comparison. We could do it the long way as I did on the previous example, but let's just use the formula. Let's just say that a is equal to the square root of a squared plus b squared, which is the square root of 1 squared plus 5 squared, which is root 26. And that now this, we're asked to write this in the format of a cos omega t plus alpha, so we need to check which rule. We're going to use that alpha is equal to inverse tan of negative a over b. And remember, when I've talked about this in class, the way to remember it is that the b is the number that belongs to cos, and the reason is just because. So just a bit of a joke there. So in this case, a is equal to 1 and b is equal to 5. So alpha is equal to the inverse tan of negative 1 over 5. Now this puts it in a different quadrant this time. This means that we've got a positive horizontal of 5 and a negative 1 from here, and that's our root 26 there, like that. So when we're looking up the inverse tan of negative 1 over 5, alpha must be negative 0.197, or if we're told that phi, not alpha, phi is positive from here, then we have to rewrite that not as negative 0.197, but we have to go around the other way and say that that's equal to 6.086. So what we've got then is that our original question can be rewritten as root 26 cosine 4t, because that's what omega is, plus 6.086. In this question, we're asked to express the given function in a particular form and then solve it for t. So we can go through pretty quickly finding a. Now it doesn't matter a or r, it doesn't matter, it's just a name. So I can find a or r, whatever. That's going to be the square root of 3 squared plus 4 squared, so that's 5. And alpha is going to be the inverse tan of, now it's a cos, so we need to use the appropriate rule for cos, which would be negative a over b. Now we need to figure out which quadrant we're in. It must be in, we've got a negative 4, so it must be that way. We've got a negative 3 from up there. So we have got like that. The hypotenuse must be 5. So our angle that we're talking about, since it must be in the third quadrant, is 0.6435. Now that's not obviously that angle. That would be the acute angle in quadrant 1, but we would have to add pi to that. So at the moment I've got it in radians, so it would be 3.785, but then of course I'd go back and I'd check that it needed to be in angles, so I would convert that to 216.9 degrees. Now we've now rewritten it into the appropriate form, so we have to now solve 5 cos 4t plus 216.9 is equal to 4. So get rid of the 5. And then we can make the substitution. And we'd solve for z. So 4 over 5 is 0.8. So z itself is going to be 36.869, and I suspect that actually that'll be too small, so we need to look at the next one, or 360 minus this, which is what, 323. So now we've got a value for z. We didn't want z, we wanted t, so t is equal to, just rearranging this, z minus 216.9 divided by 4. So our t value, now if we use the first one we're going to get a negative answer, so let's use the second one. 323 minus 216.9 divided by 4 would be 26.6 degrees. In this example we're asked to express 2 sine 5t, so omega is 5, in the format of a sine omega t minus alpha. So we need to use the rules that alpha is inverse tan of b over a, and we can use the rule that a is equal to the square root of 2 squared plus 5 squared, so 4 plus 25, which is equal to the square root of 29. Okay, back over here, alpha then must be equal to the inverse tan of now positive 5 over 2, and it gives us 1.1903. So we can rewrite it then. Our answer would be root 29 sine, put a bracket there, sine 5t, I don't need that bracket, minus 1.1903. Now I guess you'll be asking yourself, why is there an apparent sign change? So maybe it's worth at this case, at this stage, writing out the identity. A sine omega t minus alpha is equal to A sine omega t cos alpha minus A sine alpha cos omega t, and we're comparing that with 2 sine 5t minus 5 cos 5t. So what we've got is, again, I'll use red pen, is that A cos alpha is equal to 2. So A cos alpha is equal to 2. And on the other part, we've got A sine alpha is equal to 5, because the negative signs appear in both of them. So we don't make that negative 5, it is 5. So A sine alpha is 5. So that's why up here you might be saying, why is this positive, when in actual fact it kind of looks like it's negative. But for this format, that is what ends up happening, because we've got this minus sign already in there. In this last example, we've got that omega must equal 1, because there's no number there. And then, using the rules on the first slide of this presentation, alpha is going to equal inverse tan of A over B. So again, you can do it in full to prove it to yourself, but we've got that that's equal to 1 over negative 3. So alpha is going to be, it's not quite right, but so alpha is going to be negative 0.32175. And we can use the rule again to find A. A is the square root of 1 squared plus 3 squared, which is the square root of 10. So our original one then can be rewritten in the format root 10 cos t minus, now we've got a negative angle, and probably the question would have said that alpha is greater than or equal to 0. So we just need to make this then into the appropriate positive number. So it would be this. What we've got is we've got a thing that's now in the second quadrant. We've got a positive 1 and a negative root 3. That's that, and that was root 10. So what we found is the bit that's in the wrong quadrant. We found the angle that's in the wrong quadrant. So really what we're saying is that the angle is actually pi minus 0.03. Now sorry, that's a bit messy. I'll bring that down here. So we've got root 10 cos t minus pi minus 0.32175. That's just to get the right angle in the right quadrant, and that is equal to root 10 cos t minus 2.8198, which is now the right format for what the question wanted. It wanted it in the format A, cos omega t minus alpha.